Make sure that you start bringing a calculator every single day. You won't be able to do this chapter without a calculator. All right, we're going to start into trigonometry, be able to find trig ratios. Again, a ratio is just some number compared to some number. Find parts of triangles using those trig ratios. So we're going to set up equations and find missing parts of triangles. Solve problems using trig ratios. SOHCAHTOA is just a easy way that somebody came up with to help you remember your trig ratios. The SOH part, first part is sine, that's the first trig ratio, and the sine is the opposite leg over the hypotenuse. So that's sine. Sine of some angle equals opposite over hypotenuse. Next part, the co. C stands for cosine. That's the next trig ratio. And this is the adjacent leg. Remember, adjacent means the leg that's hooked to it. So the leg that's hooked to that certain angle, adjacent leg over hypotenuse. The next part, the TOA, stands for tangent. That's the T. That's the third trig ratio. And that is the opposite leg over the adjacent leg. Remember, each of these is just a ratio, so you're setting opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent as a ratio, as a fraction. All right, if it helps you, these are the trig ratios, just written in a different way. You have the sine of some angle equals the opposite leg over the hypotenuse. The cosine is the adjacent leg over the hypotenuse. The tangent equals the opposite leg over the adjacent leg. So just maybe an easier way to help you remember, whichever way is the easiest for you to remember. All right, if we're dealing with angle A, which is this angle right here, however you mark it, circle it maybe, or put that little arc in there, that's the angle we're dealing with. What very first thing you want to do every single time with your triangle is label it. The side across from the angle that you're using is called the opposite leg. The side across from the right angle is the hypotenuse. So you're going to label each of those two sides, and then the side that's hooked to the angle that you're dealing with is called the adjacent leg. So go through, just like in the 30, 60, 90 and the 45, 45, 90, very first thing you should do is label all three sides with those three labels. If we switch over to angle B, so now we're dealing with this angle. Side across from that, it switches. Now this is the opposite leg in that same triangle because we're dealing with the different angle down here. Side across from the right angle, it's not going to switch, it's still going to be the hypotenuse. And then the side that's hooked to angle B is now the adjacent leg. So when you switch angles, at first we were dealing with angle A, then we start dealing with angle B. When you switch angles, all that really changes is the opposite and adjacent legs switch locations. All right, to find the sine, cosine, and tangent of an angle. So if we want to deal with angle A, this is the angle we're dealing with. We're going to label the triangle. And I usually just write it real short. That's the opposite leg. Side across from the right angle is the hypotenuse. Side that's hooked to angle A is the adjacent leg. I just write them in there real quick so that I know where each part is. If we want to find the sine, remember your SOHCAHTOA. Sine deals with opposite and hypotenuse. Deals with the opposite and the hypotenuse. So we look back here, the opposite is 12. The hypotenuse is 13. You reduce it if it will reduce. 12 over 13 won't reduce. So that's one way to write the sine of it. The other thing that you can do is take your calculator and divide 12 divided by 13, and you come up with 0.9231. Usually when we're dealing with sine, cosine, and tangent, you always go out to the 10,000th place or out 4 decimal places. So normally, anytime you're dealing with sine, cosine, and tangent, go out 4 places. Cosine, if we look back here, adjacent and hypotenuse. So we look for the adjacent leg, which is 5, and the hypotenuse, which is 13. Again, that won't reduce any. This little symbol again, I should use that. It means approximately. When you have the wavy equal sign, it means approximately. 5 over 13, just take your calculator and divide it. 5 divided by 13. Go out 4 places, you get 0.3846. Tangent deals with opposite and adjacent. So we're going to write our fraction. Opposite leg is 12. Adjacent is 5. Notice that on sine and cosine, and something you probably want to keep in your memory there, sine and cosine always less than 1. So in sine and cosine, your top number always has to be smaller than your bottom number. Sine and cosine always has to be less than 1. Tangent isn't that way. Tangent can be whatever. But sine and cosine always has to be less than 1. 12 divided by 5, we get 2.4. So this is your fraction answer for your tangent. And this is your decimal answer for your tangent. If we do the same thing, except this time we're finding it for angle B, that means we're dealing with this angle. We want to label it a little different. This side's going to be the opposite. Side across from the right angle is the hypotenuse. This is the adjacent. Now they didn't tell us this side over here what the opposite was, but you could use Pythagorean's theorem to find that missing side. Or, if you remember the families or the Pythagorean triples that we talked about, you got 12 here, the hypotenuse is 13. Hopefully you remember that that side has to be 5. So if you use those triples, it'd make it easier to find that side. Don't forget SOHCAHTOA again. SOHCAHTOA for sine. Pen's messing up. For sine, opposite over hypotenuse. So 5 over 13. Change that to a decimal. If you remember back to the previous one, we'd already changed 5 over 13 to a decimal, 38 or 0.3846. Cosine, adjacent over hypotenuse. Adjacent is 12 over the hypotenuse, which is 13. Again, if we look back, we'd already changed 12 over 13 into a decimal, 0.9231. And something you need to remember, when you're looking at angle A one time and then looking at angle B, the sine and the cosine for each angle, for A and B, are just going to switch. Sine and the cosine just switch. So the sine of angle B is actually the cosine of angle A. And the cosine of angle B is the sine from angle A. Then for the tangent, tangent's opposite over adjacent, which is 5 over 12. Well, all that happens with the tangent, as far as angle A and angle B goes, is it's the reciprocal. It flips over the fraction. So the tangent of angle A and the tangent of angle B are the reciprocals of each other. 5 divided by 12. .4167. Now, finding all that stuff is all good, but it's not really all that real useful unless we put it towards something. And what we'd be putting it towards is either trying to find the angles or trying to find some of the sides. Well, in these cases, we knew all the sides, or we actually found this one. So what we could find is the angles, and the way we're going to do that is by using our calculator. If we know that the sine of angle B is 5 over 13, if you take your calculator, notice on your calculator it's got the sine, cosine, and tangent buttons. And what you're going to do on your calculator is sine of angle B was 5 over 13. I believe that's what it was. Yeah, 5 over 13. What we can do is you just take your calculator and you hit these buttons. You hit the second button, and you do this every time if you're looking for angle. If you're looking for an angle, then this is what you're going to do each time on your calculator. Hit the second button, hit whichever trig ratio you're dealing with. This time we're hitting the sine because we're using the sine here. And you'll notice on your screen looks something like this. It says sine -1, and it's got a parenthesis. That means you're not finding the sign, you're actually finding the angle that goes with the sign that you know. So we hit second sign, then you hit the 5 button, then hit divided by, then hit 13, or hit the 1 button, then the 3 button. You can close the parenthesis if you want. Sometimes I like to do it just to make sure I'm doing it right. And then you hit enter, or equals. And when you do all that, it tells you what that angle was, what angle B, what the actual measure of angle B in that triangle was. And mine comes up with, it says 22.619864, so on and so on. Usually when we're dealing with angles, we just round it off to the nearest degree. So we would say measure of angle B is approximately 23 degrees. Well, if we go back to this and we know angle 3 is 20, or angle B is 23 degrees, we could find the angle A just by saying 90 plus 23, it's 113, and then subtract that from 180, and you get our 67 degrees. You could also find angle A by using your calculator again and doing the same thing, and it's going to tell you that angle A is 67 degrees. So if you went back and used one of these ratios and used your calculator, it would tell you the same thing. Angle A is 67 degrees. If you have this calculator, it's the same thing. You're still going to be using sine, cosine, or tangent buttons, and you'll notice above them, and it says it on the other calculator, sine -1. Use your second button if you're looking for an angle. And we're going to do other problems that look for sides, so that'll be set up a little different. All right, on number 5. Number 5 gives you a triangle. We'll go through these sort of quickly. They give you a triangle, looks like this. Anytime they have A, B, and C as the vertices of the triangle, this book's the sides across from A is gonna be a lowercase a. Across from big B is gonna be a lowercase b. Across from big C, it's gonna be a lowercase c. And for number 5, they tell us that A is 14. B is 48, and C is 50, which fits in the 724, 25 family. You could have figured that out. They want us to find the sine, cosine, and tangent of each one. So they want us to find the sine of angle A, cosine of angle A, and the tangent of angle A. They want you to actually give the fraction and the decimal answer. I'm just going to give the fraction answer and reduce it, and then if you divide it on your calculator, you can change it to a decimal. If we're dealing with angle A, that's going to be the opposite leg. Side across from the right angle is the hypotenuse. This is the adjacent leg. Remember your SOHCAHTOA. Sine deals with opposite over hypotenuse. So that's 14 over 50. Well, 14 over 50 reduces to 7 over 25. And again, you can change that to a decimal on your own. Cosine deals with adjacent over hypotenuse, so 48 over 50. That reduces to 24 over 25. You can change that to a decimal. And then tangent deals with opposite over adjacent. The opposite is 14, the adjacent is 48. So 14 over 48. That reduces 7 over 24. You can change that to a decimal. Then they want us to do the same thing for angle B. So sine, cosine, and tangent for angle B. And what we said back here at the beginning is for angle A and angle B in the same triangle, the sine and the cosine are just switched. So the sine of angle B is going to be the same as the cosine of angle A, which was 24 over 25. Cosine of angle B is going to be the same as the sine of angle A, which was 7 over 25. And then the tangent is just the reciprocal of whatever we had right here. So you just flip that over, that's 24 over 27. So that's number 5. Number 6 is the same idea. I'm not going to do number 6. Number 6, same idea, just using different numbers, 8, 15, and 17. Number 7, 7, 8, 9, and 10. You're just going to, 11 and 12 also. You're just going to use your calculator. So you grab your calculator, and all you're actually doing this time on your calculator for number 7, these are the buttons you're going to hit. You're going to hit the sine button first this time, and then you just hit 5, 7, and again, I like to close my parenthesis because the calculator shows a parenthesis, so I hit that parenthesis button. You don't necessarily have to. You could also use the chart to look up the sine of 57 on the chart that I passed out in class. And you get 0.83867. So I'm going to round that to point. I'm not sure why my pen's not right. 0.8387. Number 8, you do the same thing. Number 8, except this time you hit the cosine button. Cosine, and you punch in 60, hit enter. You get 0.5. Number 9, cosine again, 33. You get 0.8387. Notice for these two, they were the same thing because 57 and 33 add up to be 90. So they're the ones that we were talking about, the sine of one angle and the cosine of the other angle. Number 10 is the tangent of 30. So we hit tangent 30, hit enter. You get 0.5774. Number 11, tangent of 45. And you get 1. The reason for that, because if it's a 45-degree angle, that means it's got to be a 45, 45, 90 triangle. And we know that this leg and this leg are the same thing. Well, L over L, no matter what they are, is always going to give you 1. Then number 12, sine of 85 degrees, you get 0.9962. Notice again that the tangent's the only one that's 1 or higher, sine and cosine on all of them are all less than 1. Problem 13 says tangent angle A equals 1.4176. So what you're actually trying to do is find angle A this time. So again, you're going to use your calculator. Only this time you're going to hit the second button, then hit tangent. And again, your screen is going to pop up tan -1. That looks like that. And all you're going to do is plug this number into there. So you hit second, tangent, 1.4176. You can close the parenthesis if you want. And then it gives you 54.8001834. So we're just going to say we're going to round off angles to the nearest degree. Measure of angle A is about 55 degrees. Number 14, same idea on 14, except this time it's sine. So you hit on your calculator, you hit second sine, and you punch in the number that they give you, which is 0.6307. Hit enter, and it tells you 39.1017. So we're going to say, we're going to round it off and say that the angle is about 39 degrees. All right, on number 17, they say that this person's standing out here somewhere on horizontal ground, looking up at something, they're seeing the CN Tower in Toronto. And they tell us that the angle is 31.2 degrees. So that's that angle right there where she's looking up at it. You need to draw her in here, you could. You got your tower over here. I'm not going to draw the tower. Shouldn't go down past the ground. Let's see. She knows that the height of the tower to the top of the antenna is about 1,815 feet. So 1,815 feet over here. That's how tall the tower is. Find her distance from the tower. So we're looking for this distance. Every time you do one of these, a problem where you're using trig ratios to find a missing side, what you're going to do every single time is set up an equation. First thing you got to do is know which angle you're dealing with. Well, this is the angle they tell us, so that's the angle we're going to deal with. Label your sides. That's the opposite leg. That's the hypotenuse. This side over here then is the adjacent leg. Remember your SOHCAHTOA. And you got to decide which one of those three trig ratios you're going to use. Well, usually there'll be one side that you don't care about. This time we really don't care about the hypotenuse. We know the opposite and we're looking for the adjacent. And you got to figure out which of these three trig ratios deals with opposite and adjacent. Well, it's tangent this time. So when we set up our equation, it's always one of the trig ratios, then our angle next. Well, our angle this time is 31.2 equals, and then our two sides at a ratio to each other. And it's opposite over adjacent. So the opposite side is 1815. The adjacent is x. That's the part we don't know. And what I like to do first on this is I put a 1 underneath that to make it a proportion. Now it looks just like everything else that we've been solving for the last couple of chapters. Next thing I do, all this stuff stays the same. And I take my calculator and I get rid of that tangent word there. All you got to do on your calculator, you hit tangent, don't hit second this time, just hit tangent, 31.2, hit enter, and it'll tell you what the tangent is. and you write that number out 4 decimal places in there. Now you just have a proportion that you can solve. We cross multiply, 1 times 1815 is just 1815.6056 times x. And we divide both sides by 0.6056 to solve for the x. And I get about, I'm gonna round it off, about 2,997 feet. That's how far she is from the tower. All right, this is your assignment, page 368.